In this problem, we will numerically estimate the instantaneous rate of change of the function. This is a quadratic function, f of t equals 2t squared minus 8t plus 1. We're going to find the instantaneous rate of change at t equals 3 using tables of average rates of change, and we're going to use desmos to help with this. In desmos, I've defined the function. I've also plotted and labeled the point that we're interested in at t equals 3. We're going to add a table. We're interested in having desmos display average rates of change from t equals 3 to points very, very near t equals 3. So we're going to plug an input of h and an output of f of 3 plus h minus f of 3 all over h, the difference quotient at t equals 3. This will calculate the average rate of change from t equals 3 to t equals 3 plus h. We can now plug in values like 0.1 for h, 0.01 for h. Now notice, as I plug that in, it's actually plotting points over here on the graph, and I don't want it to do that. So I'm going to put my cursor on the little black dot in the y value of the table and turn that off and continue here. And I'm going to have an h of 0.001 and then one more, 0.0001. The average rate of change from t equals 3 to t equals 3.1 is 4.2. The third row of the table, the average rate of change from t equals 3 to t equals 3.001 is 4.002. In general, we see that the right-hand limit of these average rates of change is 4. The closer and closer the points get to t equals 3 from the right, the closer and closer the average rates of change get to 4. Similarly, I can create an input-output table to explore the left-hand limits of the average rates of change at t equals 3. So I'm going to plug in f of 3 plus h minus f of 3 all over h. I'm going to again input h values. This time I'm going to explore points that are getting closer and closer to t equals 3 from the left. So I let h be negative 0.1 and negative 0.01 and negative 0.001 and so forth. So the first row of the table, for example, is saying the average rate of change of f of t from t equals 2.9 to t equals 3. That average rate of change is 3.8. Notice that means h is negative 0.1. The point is 0.1 units to the left of t equals 3. The third row of the table tells us that the average rate of change from t equals 2.999 to t equals 3, that has an average rate of change of 3.998. That point, t equals 2.999, is 0.001 units to the left of t equals 3. Again, here we see that the table is telling us that the average rates of change as we approach from the left side, those average rates of change are approaching 4. In general, the right-hand limit is 4, the left-hand limit is 4. The average rates of change are getting closer and closer to 4 as we explore points that are getting closer and closer to t equals 3. Therefore, we would conclude the instantaneous rate of change of f of t at t equals 3 is 4. So the left-hand limit of that difference quotient is 4, the right-hand limit of that difference quotient is 4, the overall limit of that difference quotient is 4. So we conclude the instantaneous rate of change of f of t at t equals 3 is 4. The slope of the tangent line to f of t at the point 3, negative 5 is 4. The equation of that line has a slope of 4. It passes through the point 3, negative 5, so this would be the equation of that line.